In this video, we're going to talk about how to find the partial derivative with respect to a certain variable. So for example, let's say if we have a function that consists of multiple variables, in this case x and y. And let's say it's equal to 7x squared minus x cubed y to the fourth plus 5x to the fourth y cubed. So what is the partial derivative of this function with respect to x? How can we find the answer? The partial derivative with respect to x is symbolized by the variable f sub x. Now, in order to find it, every other variable, in this case y, you need to treat it as a constant. You only treat x as the variable. Everything else, you view it as a constant. Now, before we do this problem, let's review the power rule. Let's say if we have a function x to the n. If we wish to find the derivative, it's going to be nx raised to the n minus 1. So for example, the derivative of x to the fourth is 4x cubed. The derivative of x cubed is 3x squared. The derivative of x to the fifth is 5x to the fourth. The derivative of x squared is 2x to the first power. The derivative of x, or x to the first power, is 1x to the 0, which is the same as 1. So what is the derivative of x squared? The derivative of x squared is 2x. Now what about the derivative of x cubed? We know it's 3x squared. Now y, we're going to treat it as a constant, so we're just going to rewrite it. The derivative of x to the fourth is 4x cubed. And then we won't change the y to the third. So that's how you can find the first derivative, the first partial derivative with respect to x. Treat x as a variable, and any other variable treat it as a constant. So this is equal to 14x minus 3x squared y to the fourth plus 20x cubed y to the third. So that's the answer. That's the first partial derivative with respect to x. Now what about the partial derivative with respect to y? What is the answer in that case? So 7x squared is treated as a constant. The derivative of a constant is 0. The derivative of y to the fourth is 4y cubed. And the derivative of y to the third is 3y squared. So in this case, we need to treat x as if it's a constant. So this is going to be negative 4x cubed y cubed plus 15x to the fourth y squared. So that's the partial derivative with respect to y. Let's try another example for the sake of practice. Let's say z is equal to 3x squared y to the fourth minus 5x to the seventh plus 4y to the eighth. Find the first partial derivative with respect to x and with respect to y. So if you see z is basically a function of x and y. So you can write it as f of x comma y or just z, it doesn't matter. Now the first derivative with respect to x is going to be, so keep in mind, let's treat y as a constant. So differentiate only the x variables. The derivative of x squared is 2x. And the derivative of x to the seventh is 7x to the sixth. Now, in the last term, there is no x variable. So 4y to the 8 is treated as a constant, and the derivative of any constant is 0. So this is going to be 6x y to the fourth minus 35x to the sixth. So that's the first partial derivative with respect to x. Now let's find it with respect to y. So let's treat x as a constant. So the derivative of y to the fourth is 4y cubed. 5x to the seventh is a constant, so that's going to become 0. And the derivative of y to the 8 is 8y to the seventh. 3 times 4 is 12. And 4 times 8 is 32. So this is the answer. That's the partial derivative with respect to y. Now let's work on an exponential function. Let's say z is equal to e raised to the x squared times y cubed. What is dz dx and dz dy? So as you recall, z is the same as f of x comma y. So dz dx is the partial derivative with respect to x. That's the same as f sub x. And dz dy is the partial derivative of the function z with respect to y, which is the same as fy. So if you see those symbols, you know what they mean. So now, let's talk about the derivative of an exponential function. The derivative of e to the u is equal to e to the u times u prime. So let's say if we want to find the derivative of e to the x cubed, it's going to be the same thing, e to the x cubed times the derivative of x cubed, which is 3x squared. So if we want to find the derivative of e to the negative 5x, it's going to be e to the negative 5x times negative 5. And e to the x is going to be the same thing times the derivative of x, which is 1. So I want to give you some examples so you know how to use this formula. Now let's apply that to the problem that we have. Let's just get rid of this portion. Let's keep the formula there. So let's find dz dx. So it's going to be e to the u, which is e to the x squared y cubed. It's going to be the original expression times the derivative of x squared y cubed. Now we want to find the partial derivative. That means we want to treat y as a constant. So we're going to differentiate x squared, which is 2x, and rewrite y cubed. And that will be it. We don't have to use a product rule here. We're just only differentiating the x variable. And so that's it. It's going to be 2x y cubed times e raised to the x squared y cubed. Now let's find dz dy. So if z is equal to e x squared y cubed, let's differentiate both sides with respect to y. So you can represent it using the symbol d over dy. So on the left, we're going to have dz dy, and on the right, it's going to be the same thing, e to the u, which is e to the x squared y cubed, times the derivative of x squared y cubed. So we're going to treat x squared as a constant. So we're going to rewrite it and multiply by the derivative of y cubed, which is 3y squared. So the answer is 3x squared y squared e to the x squared y cubed. So that's dz dy, which is the same as f sub y. So here's a problem that you could try for practice. Let's say z is equal to x to the 4th, e raised to the y to the 5th. Find the first partial derivative with respect to x and with respect to y. So go ahead, take a minute, and pause the video. So let's find dz dx. So notice that x to the 4th is the variable, and e, y to the 5th is the constant because it doesn't have an x variable. It only has a y variable. So we're going to differentiate x to the 4th, which is 4x cubed, and then simply rewrite the constant. So that's dz dx. Now dz dy, x to the 4th is now the constant, so we're just going to rewrite it. And then differentiate e, y to the 5th. So using this formula, it's going to be the same thing, e raised to the y to the 5th, times the derivative of y to the 5th, which is 5y to the 4th. And so these are the two answers. Now let's say that f of x comma y is equal to the natural log of x squared plus y squared. Go ahead and find f of x, the partial derivative with respect to x, and fy. So first, you need to know how to differentiate natural log functions. The derivative of ln u is equal to u prime divided by u. So for example, if we want to find the derivative of ln x squared plus 8, it's going to be the derivative of x squared plus 8, which is 2x, divided by whatever stuff was on the inside of the natural log function, which is x squared plus 8. So let's say if we want to find the derivative of ln x cubed plus 5x minus 9, it's going to be the derivative of the inside function, which is 3x squared plus 5, divided by the original of the inside function. So for example, if we want to find the derivative of ln x, it's going to be the derivative of x, which is 1, divided by the original stuff on the inside, which is x, so you get 1 over x. So now let's solve the problem that we have. Let's find f of x. So it's going to be the derivative of the stuff inside, that is the derivative of x squared plus y squared. The derivative of x squared is 2x, and y squared, we're going to treat it as a constant because we're trying to find the partial derivative with respect to x. So y squared is 0, divided by the original x squared plus y squared. So it's simply 2x over x squared plus y squared. Now, if you want to find f sub y, it's going to be the derivative of y squared, which is 2y. X squared is a constant, so that becomes 0, divided by the original x squared plus y squared. So this is the first partial derivative with respect to y, and this is the first partial derivative with respect to x. Here's one you could try. It might be a little challenging, but go ahead and try it. Let's say z is the natural log of x squared divided by y. Go ahead and find dz dx and dz dy. So the derivative of the natural log of u, we know it's u prime over u. So u is basically the function on the inside, which is x squared divided by y, which I'm going to write it as x squared times 1 over y. So now what's u prime? It all depends on if we're looking for dz dx or dz dy. Let's find dz dx first. So u prime, which I'm going to write it as u prime with respect to x, we're going to treat x as a variable. So the derivative of x squared is 2x times the constant 1 over y. We're going to treat 1 over y as a constant. So now dz dx is going to be the same as u prime over u. U prime is 2x times 1 over y, divided by u, which is x squared times 1 over y. So we can cancel 1 over y, and we can cancel an x. So we're left over with 2 divided by x. So that's the answer for the partial derivative with respect to x. Now let's find it with respect to y. So let's find u prime with respect to y. So x squared is going to be treated as a constant this time, so we can rewrite it. Now 1 over y is y to the minus 1, and the derivative of y to the minus 1 is negative 1, y to the minus 2. So u prime with respect to y is negative x squared times 1 over y squared. So we're going to write it like that. So using this formula, u prime over u, dz dy is going to be u prime, which is negative x squared times 1 over y squared, divided by the original u value, which is x squared times 1 over y. So we can get rid of the x squared term, and let's multiply the top and the bottom by y squared to simplify the complex fraction. So these will cancel. So on top, we're just going to have a negative 1. On the bottom, y squared divided by y is y. So this is the first partial derivative with respect to y. It's negative 1 over y. Now let's try a problem involving square roots. So let's say f is equal to the square root of x squared plus y squared. Find a partial derivative with respect to x and y. So first, let's rewrite it. So this is equal to x squared plus y squared raised to the 1/2. So let's find the partial derivative with respect to x. So we need to bring the 1/2 to the front. And we're going to keep everything on the inside the same. So basically, we need to use the chain rule, so to speak. Now, 1/2 minus 1, that's negative 1/2. And now we need to find the derivative of the inside function with respect to x. The derivative of x squared is 2x. And for y squared, we're going to treat that as a constant, so that's 0. 1/2 times 2 is 1. So therefore, the final answer, we can also bring this down because it's negative 1/2. So the final answer is going to be x on top divided by x squared plus y squared raised to the positive 1/2. When you move it from the top to the bottom, the exponent will change sign. It's going to change from negative to positive. So you can write the final answer as x divided by the square root of x squared plus y squared. So that's the first partial derivative with respect to x. Now, what about with respect to y? So we're going to take the exponent and move it to the front and keep the inside the same, and then subtract 1/2 by 1, which will give us negative 1/2 again. And now we need to differentiate the inside function. X squared will now be treated as a constant, so that's 0, and y squared is 2y. So as you can see, everything is going to be the same, but we're going to have a y variable on top instead of an x variable. So this is the final answer. It's y over the square root of x squared plus y squared. Now let's try a trig function. Let's say z is equal to sine x cubed y to the 5th. Find dz dx and dz dy. So if you want to find the derivative of a sine function, the derivative of sine u is cosine u times u prime. So if we want to differentiate sine x squared, it's going to be cosine x squared times the derivative of the inside part. The derivative of x squared is 2x. So let's say if you have sine x to the 5th, it's going to be cosine x to the 5th times the derivative of x to the 5th, which is 5x to the 4th. So now let's work on the problem that we have. So let's find dz dx. The derivative of sine is cosine, and whatever is inside of sine, we're going to keep it the same. We're not going to change it. So it's going to be x cubed y to the 5th. And now we need to differentiate x cubed y to the 5th with respect to x. So we're going to treat x as the variable, y as the constant. The derivative of x cubed is 3x squared, and then we're going to multiply by the constant. So that's the answer, which we can write it as 3x squared y to the 5th, and then cosine x cubed y to the 5th. Now let's find dz dy. So it's going to be cosine x cubed y to the 5th. The first part is not going to change, but the second part will. Now, x cubed is the constant, y to the 5th is the variable. So we can rewrite the constant times the derivative of y to the 5th, which is 5y to the 4th. So that's 5x cubed y to the 4th times cosine x cubed y to the 5th. And so that's going to be the answer. Now let's say if we're given a function f of x comma y, which is 2x cubed y squared plus 5y cubed plus 4x squared. And we need to evaluate f of x and f of y at the point 1, 2. How can we do so? Well, first, let's find a partial derivative. With respect to x is going to be the derivative of x cubed, which is 3x squared. We're going to treat y squared as a constant. The derivative of this constant becomes 0, so we can ignore it. And the derivative of 4x squared is 8x. So now we can plug in the point 1, 2. 2 times 3 is 6, times 1 squared, times 2 squared, and we're going to have 8 times 1. So 2 squared is 4, times 6, that's 24, plus 8, so that's 32. So that's the value of the first derivative with respect to x at the point 1, 2. Now let's do the same for fy. So first we got to find it. Let's treat x as a constant. The derivative of y squared is 2y, and the derivative of y cubed is 3y squared. And 4x squared is a constant, so that becomes 0. Now let's plug in the point 1, 2. 5 times 3 is 15. So here we have 2 times 2 times 2, which is 8. 2 squared is 4 times 15, that's 60. 8 plus 60 is 68. And so that's all you need to do in order to evaluate the derivative at the point. Find the derivative and plug in the x and y values. Here's another example, but this one might be more trickier. Let's say we have a function, it's equal to x cubed e raised to the 4xy squared. And let's evaluate the partial derivative with respect to x and y at the point 2, 0. So how can we find fx and fy? Now here's where we need to be careful. When looking for f of x, you need to use the product rule, because the x variable is in the first part of the function and it's in the second part. But when finding fy, you don't need to use the product rule. So for example, let's say if you have 4x to the fifth, you have a constant multiplied by a variable. You do not need to use the product rule here. This is simply going to be just 20x to the fourth. Now let's say if you have 4x squared times e to the third. Here you have a variable and a constant. You don't need to use the product rule. This is simply going to be 8x e to the third. However, if you have 4x squared times e to the 3x, you have a variable and a variable here, so you do need to use the product rule. So in the case for this problem, when differentiating with respect to x, we have an x variable here and here, so we got to use the product rule. But when differentiating with respect to y, x is treated as a constant. So we have a y variable on the right, but we don't have a y variable on the left. X cubed is treated as a constant, so we don't need to use the product rule in that case. So I want to just help you to see when you should use the product rule and when you shouldn't. So let's start with fy, because we don't need to use the product rule. So it's going to be the constant, which is x cubed, and then all we got to do is differentiate e to the 4xy squared, which is going to be the same thing, e to the 4xy squared times the derivative of 4xy squared. So 4x is a constant, and the derivative of y squared is 2y. So now we can plug in the point 2, 0. So x is 2, and this is going to be 2 to the third. And we're going to have e raised to the 4 times 2 times 0 squared. 0 times anything is 0. And then it's going to be 4 times x, which is 2, times 2, and y is 0. So because we have a 0 here, the whole thing is 0. So that's the partial derivative with respect to y. Now let's find it with respect to x. So let's review the product rule. Let's say if we have two functions, f times g. You need to differentiate the first function, so you're going to get f prime times the original of the second plus the original of the first times the derivative of the second. So that's how we're going to use the product rule. So first, let's differentiate the first part, x cubed, which is 3x squared, and then we're going to rewrite the second part. We're not going to change it. Plus, we're going to rewrite the first part, x cubed, and then differentiate the second part. So the derivative of e to the 4xy squared with respect to x is going to be e to the 4xy squared, and the derivative of 4xy squared with respect to x is going to be 4 times y squared, where y squared is a constant. So because the variable x was in both parts, we had to use the product rule. Now let's plug in the point 2, 0. So x is 2, And because we have a y squared, 4xy squared will become 0. So this will be e to the 0 again. And we have a y squared here, so this whole thing will be 0. 2 squared is 4, and 3 times 4 is 12. Anything raised to the 0 power is 1. 2 to the third is 8, and 4 times 0 is 0. So this is going to be 12, and 8 times 0 is 0, so the final answer is 12. So the first derivative with respect to x is 12, and the first derivative with respect to y is 0. Consider this problem. Let's say f of x comma y is equal to 3y to the fifth divided by x cubed plus y cubed. So go ahead and find a partial derivative, the first one with respect to x and with respect to y. Now here's a question for you. Do we need to use the quotient rule? If you recall, let's say if we wish to differentiate f divided by g, where f and g are both functions that contain variables. It's going to be g f prime minus f g prime over g squared. Now, when differentiating with respect to x, 3y to the fifth is a constant, and x cubed is a variable. So we don't have a variable on the top and on the bottom. So for f of x, we don't need to use the quotient rule. Now, when differentiating with respect to y, we have a y variable on the top and on the bottom, so we do need to use the quotient rule with respect to y. And so that's how you can tell. So let's start with f of x, where we don't need to use the quotient rule. So imagine if you were differentiating, let's say, 4 over x cubed plus 7. If that's the case, what you could do is rewrite the function as 4 x cubed plus 7 to the minus 1 and simply use the power rule. That's what we're going to do in this example. So first I'm going to rewrite it as 3y to the fifth times x cubed plus y cubed raised to the minus 1. So f of x is going to be the constant 3y to the fifth. Then I'm going to take the negative 1, move it to the front. So it's going to be times negative 1. And then I'm going to keep the stuff that's inside the brackets the same. Subtract negative 1 by 1. And that's going to be negative 2. And then differentiate the stuff on the inside. The derivative of x cubed is 3x squared. And the derivative of y cubed is 0, because we're going to treat it as a constant. So this is going to go to the bottom, making this exponent positive, and everything else will stay on top. So we got 3 times 3, which is 9, plus a negative sign. So it's negative 9 x squared y to the fifth divided by x cubed plus y cubed squared. So that's the first derivative with respect to x. Now let's find fy, the first derivative with respect to y. And we're going to have to use the quotient rule. So f is going to be the top function, 3y to the fifth. G is the bottom part, x cubed plus y cubed. Now f prime with respect to y, it's going to be 3 times 5y to the fourth, which is 15y to the fourth. G prime with respect to y is going to be 3y squared. The derivative of x cubed, which we're going to treat as a constant, is 0. So now let's plug it in into this formula here. So f of y is going to be g, which we know g is just x cubed y cubed, times f prime, which is 15y to the fourth, minus f, which is 3y to the fifth, times g prime, which is 3y squared, all divided by g squared, which is x cubed plus y cubed squared. So now let's see what we can do to simplify this expression. So if we want to, we could distribute 15y to the fourth, or we can factor out 3y to the fourth. Let's factor out 3y to the fourth. If we do so, we'll be left with a 5 times x cubed plus y cubed. So that's 5x cubed plus 5y cubed. Now here we took out the 3 and y to the fourth, so we're left over with y. And that y is going to be multiplied by 3y squared, so it's negative 3y cubed. Don't forget about the negative sign. Divided by this stuff. So we can combine 5y cubed and 3y cubed. So the final answer is 3y to the fourth times 5x cubed plus 2y cubed divided by x cubed plus y cubed squared. So that is f of y. Now let's say if you're given a function that looks like this, x squared y cubed, and you want to find the slope of the surface in the x and y direction at the point 3, 2. All you need to do is find fx and fy and evaluate the function at this point. And that's going to give you the slope of the surface in the x and y direction. So to find the slope in the x direction, it's simply fx 3, 2. So we just got to plug in, well, first we got to find fx. Fx is going to be the derivative of x squared, which is 2x, times the constant y cubed. So fx 3, 2 is going to be 2 times 3 times 2 to the third power. 2 times 3 is 6, 2 to the third power is 8, and 6 times 8 is 48. Now let's find fy. That's going to be x squared times 3y squared. And so fy, the slope of the surface in the y direction, is going to be, this is fy 3, 2. It's going to be 3 squared times 3 times 2 squared. 3 squared is 9, and 2 squared is 4. 3 times 9 is 27, and 27 times 4 is 108. So these are the answers that we're looking for. Now sometimes you may have a function with 3 variables instead of 2. Let's say we have f of x, y, and z, and it's equal to x to the fifth, y squared, z to the fourth. Now let's find the first 3 partial derivatives with respect to x, y, and z. So what is the partial derivative with respect to x? Now the rules are the same. We're going to treat x as the variable, and every other variable we're going to treat it as a constant. So the derivative of x to the fifth is 5x to the fourth. So y squared and z to the fourth will be treated as a constant, and according to the constant multiple rule, we just multiply the derivative of the variable times the constant to get the derivative of the function with respect to that variable. So that's f of x. Now let's find f of y. So x to the fifth is a constant. All we need to do is differentiate y squared, which is 2y, and z to the fourth is the same. So when looking for f of x, differentiate just x to the fifth. When looking for f of y, differentiate only the y squared part. And when looking for f of z, differentiate just the z to the fourth part. So f of z is going to be x to the fifth, y squared, times the derivative of z to the fourth, which is 4z cubed. And so that's how you can find a partial derivative with respect to x, y, and z. So let's say w is equal to z to the third times ln zy times e raised to the x squared y cubed z to the fourth. So find dw dz, dw dy, and dw dx. Feel free to pause the video and be careful with this one. So let's start with dw dx. So do we need to use a product rule for this? In terms of x, we have a constant and a variable. So we do not need to use the product rule. So z to the third is a constant, so we can rewrite it. ln zy will be treated as a constant. And the derivative of e to the u is e to the u times u prime. So it's going to be the same thing, ex squared y cubed z to the fourth times u prime, or the derivative of x squared y cubed z to the fourth. X squared is the only variable, so we just got to differentiate that part, which is 2x, times the constant y cubed z to the fourth. So that's dw dx. Now, what about dw dy? Do we need to use the product rule? It turns out we do. Here we have a constant. Here it is a variable because there's a y in it. And here this is another variable. So we got two variables multiplied to each other. So therefore, we need to use this form of the product rule. The derivative of two variables multiplied to each other is the derivative of the first times the second plus the first times the derivative of the second. So the first part is this part, because that's the first time the variable shows up, and this is the second part, and that's just a constant. So we can rewrite the constant, z to the third, and then let's differentiate the first part, ln zy. The derivative of ln u is u prime over u. So the derivative of zy is simply z times 1, or z. We're just differentiating the y variable, divided by the original zy, times the other function, which is ex squared y cubed z to the fourth. So this part is like f prime, and this is g. Now for the second part. So let's rewrite the constant z to the third. F is basically the first time we see the variable ln zy, which we're just going to rewrite it as ln zy. And then g prime, the derivative of the second part, that's going to be e to the u, which is ex squared y cubed z to the fourth, and then times u prime, which we're differentiating the y variable, so it's going to be x squared times the derivative of y cubed, which is 3y squared, times the constant z to the fourth. And I'm running out of space. So let me get rid of this formula, and let's simplify what we have. So we can cancel a z, and we can combine z to the third and z to the fourth. So dw dy is equal to z to the third times ex squared y cubed z to the fourth divided by y, plus 3x squared y squared z to the third times z to the fourth, that's z to the seventh, and then ln zy times x squared y cubed z to the fourth. If you want to, you can factor out x squared y cubed z to the fourth, and you can also take out z to the third if you want to. But we're not going to worry about that, so I'm just going to leave the answer the way it is. Now let's find the other one, dw dz. So notice that z is found in each term. So we need to use a product rule with three variables. That's f times g times h. So it's going to be the derivative of the first part, f prime, times the other two, plus f times the derivative of the second part, times h, plus fg times the derivative of the third part, h prime. So in this particular example, z to the third is basically f. ln zy is g, and h is the e raised to all of that stuff. So let's find f prime. That's going to be 3z squared times everything else, ln zy and e to the x squared y cubed z to the fourth, plus f, which is z to the third, times g prime. So that's going to be u prime over u. The derivative of zy with respect to z is simply y divided by the stuff on the inside, which is zy, and then times e to the x squared y cubed z to the fourth, and then plus the third part, which is going to be z to the third times ln zy times the derivative of this thing, which is ex squared y cubed z to the fourth, times the derivative of the exponent, which is x squared y cubed times 4z to the third. So that's the answer for dw dz. You have to use the product rule with three different variables. When I mean three variables, I mean f, g, and h. But z is just one variable. That's the only thing that we're differentiating. Now let's see if we could simplify our expression. Let's factor out the greatest common factor. So we can take out e to the x squared y cubed z to the fourth. That's a common term. And we can also cancel a y, and z will cancel, so that becomes a z squared. So we could take out a z squared from every term. So let's put that here. Now, so this is gone, and we took out the z squared. So we're left over with 3 times ln zy. In the second term, we took out this, all of that is gone, and we took out all of the z squared. So there's nothing left in the second term, so we could just put a 1. For the last term, we took this out. We took out z squared, so we're left with z. And we have ln zy and everything here. So it's going to be 4 x squared y cubed, and then z to the third times z. That's going to be z to the fourth, and then ln zy. So we can write the final answer like that if we want to. Now let's say if we have this function. And all we want to do is evaluate the first partial derivative with respect to y at the point 1, 2, 3. So x is 1, y is 2, z is 3. Go ahead and try that. So first, let's find fy. So the derivative of y squared is 2y. The second term doesn't have a y variable, so the whole thing is a constant. That becomes 0. And the derivative of y is 1. So that's fy. So now we can evaluate it at the point 1, 2, 3. So x is 1 and y is 2. And z is 3. So 2 times 2 is 4, and 3 to the fourth power is 81. That's 3 times 3 times 3 times 3. 4 times 4 is 16. Now 5 times 8 is 40, so 5 times 80 is 400. And 5 times 1 is 5, so 5 times 81 is 405. Plus 16, that's 421. So that's the rate of change of the function with respect to y at the point 1, 2, 3. So sometimes you may be asked to identify just one of the partial derivatives at a certain point, and that's how you do it. Now sometimes you may need to find higher order partial derivatives. So let's talk about the difference between the first derivative and the second, and the different forms in which they can come in. So let's say we have our original function f. If we differentiate f with respect to x, we can get the first derivative with respect to x, which is known as f of x. We could also differentiate f with respect to y, and we'll get the first partial derivative with respect to y, which is known as fy. Now at this point, we could differentiate the first derivative with respect to x. So the second derivative is going to be fxx, which means that we found the derivative with respect to x twice. Now we could differentiate fx with respect to y, and we'll get fxy, which means that we differentiated first with respect to x, and then second we differentiated with respect to y. Now fy, we could differentiate it with respect to x, and we'll get fyx, which means that we differentiated first with respect to y, and then with respect to x. Or we could differentiate fy with respect to y, which is fyy, which means we differentiate the function twice with respect to y. So when dealing with second partial derivatives, if you have a function with two variables, there are four derivatives that you can get. Now let's say if we have the function x to the third plus 4x to the fifth y cubed plus 5y to the fourth. So find all four second partial derivatives. So find fxx, fxy, fyx, and fyy. Feel free to pause the video. So first, let's find fx. Let's find the first partial derivative with respect to x. The derivative of x cubed is 3x squared. And the derivative of x to the fifth is 5x to the fourth times the constant y cubed. And 5y to the fourth is a constant, so that's going to be 0. So that's fx, which we can write it as 3x squared plus 20x to the fourth y cubed. So now let's find f double x. So 3x squared will become 6x, and x to the fourth is 4x cubed, and 20 times 4 is 80, so we can write it as 80x cubed y cubed. So that's our first answer. Now let's find fxy. So let's differentiate this function with respect to y. 3x squared will become 0, and the derivative of y to the third is 3y squared. So this is 60 x to the fourth y squared. And so that's it for this one. Now let's find fy. So we could find fyx and fyy. So x cubed is now a constant, that becomes 0. And y cubed, the derivative of that is 3y squared. And the derivative of y to the fourth is 4y cubed. So fy is equal to 12 x to the fifth y squared plus 20 y cubed. Now from this function we could find the other two answers we're looking for. So let's find f double y. Let's differentiate it with respect to y one more time. So it's going to be 12x to the fifth times 2y plus 20 times 3y squared. So that's equal to 24x to the fifth y plus 60 y squared. So that's f double y. Now let's find fyx. So let's differentiate this function with respect to x. The derivative of x to the fifth is 5x to the fourth. And with respect to x, y cubed is a constant, so 20y cubed becomes 0. So the final answer is 12 times 5, which is 60, x to the fourth y squared. So that is the second derivative, where we differentiate with respect to y and then with respect to x. Here's another problem. Let's say f is equal to x cubed y to the fourth plus z squared x cubed y plus 4x cubed z to the fourth. So this time we're going to find a mixed partial derivative, but a third derivative instead of a second order derivative. So let's find the mixed third order derivative. Let's say f x y z. Go ahead and find it. So first we got to find f of x. We got to differentiate the function with respect to x. So x cubed will become 3x squared, and then we have another x cubed, which is 3x squared again, times y, and the derivative of 4x cubed is 12x squared, z to the fourth. So now we're going to differentiate the function with respect to y. So y to the fourth will become 4y cubed, and the derivative of y is 1. Now, 12x squared z to the fourth doesn't have a y variable, so that becomes 0. Now we're going to differentiate fxy with respect to z. Now this term doesn't have a z, so that's going to become 0. Z squared is 2z times 3x squared. So the final answer is 6zx squared, or 6x squared z. Now let's try another example using the same function. This time, let's find f y x x. So first let's find fy. So this will become 0 because there's no y variable. The derivative of y to the fourth is 4y cubed, and the derivative of y is simply 1. So this is what we have left over. Now let's find fyx. Let's differentiate this function with respect to x. The derivative of x cubed is 3x squared. Now let's differentiate that function again with respect to x. 3 times 4 is 12, and the derivative of x squared is 2x. And the derivative of 3x squared is 6x. So the final answer is 24xy cubed plus 6xz squared. So that's the third order mixed partial derivative, where we differentiate y first and then x and then by x again. There's a theorem that you need to know related to this section, and that is the equality of mixed partial derivatives. So if the function is continuous, then you need to know that fxy is equal to fyx. So if you differentiate with respect to y once and with respect to x once, the order doesn't matter. These two mixed partial derivatives are equivalent to each other. So let's say if you want to find a third order derivative, f of x, y, z is the same as f of y, x, z, which is the same as f of z, x, y. All of these three mixed partial derivatives are the same. We differentiated with respect to x once, with respect to y once, and with respect to z once. The order doesn't matter. So here's another example. F of y, x, y is equal to f of x, y, y, which is equal to f of y, y, x. These are all the same. We're differentiating with respect to x once, but with respect to y twice. So let's prove it. So let's say we have a function that's x squared y cubed plus 4x y squared. And let's prove that f of xy is equal to fyx. So let's find f of x first. F of x is 2x y cubed plus 4y squared. Now let's find f double x. So let's differentiate with respect to, well, let's find f of xy I meant. The derivative of y cubed is 3y squared times 2x. That's 6xy squared. And the derivative of 4y squared is 8y. So now let's find f yx. So first we got to find fy using this function. The derivative of y cubed is 3y squared, so we're going to have 3x squared y squared. And the derivative of y squared is 2y times 4x. That's 8xy. Now let's differentiate this function with respect to x. The derivative of 3x squared is 6x times y squared. The derivative of 8x is simply 8. So notice that these two are the same. fxy is equivalent to fyx. Now let's say that f is 4x squared y cubed z plus 6x y squared z squared. And let's show that f of x yy is equal to f of y xy, and let's show that's equal to f yx. So first, let's find fx. Let's differentiate this function with respect to x. So the derivative of 4x squared is 8x times the constants y cubed z. The derivative of 6x is 6, and then times y squared z squared. Now we need to differentiate fx with respect to y. So it's going to be the derivative of y cubed, which is 3y squared times 8. So that's 24x y squared z. And the derivative of 6y squared is 12y times z squared. Now let's differentiate it again with respect to y. So y squared becomes 2y times 24. So that's 48xyz. And the derivative of 12y is just 12. So let me write this somewhere. Let's just separate this. So f of x yy is equal to 48 xyz plus 12z squared. Let's just write that for reference. We'll compare it later. So now let's find f yxy. So first let's find fy. The derivative of y cubed is 3y squared times 4. So that's 12x squared y squared z. And the derivative of y squared is 2y times 6, which is 12xy z squared. Now let's differentiate that function with respect to x. The derivative of x squared is 2x, so 12x squared is 24x times y squared z. And the derivative of 12x is just 12y z squared. Now let's differentiate that function, this one, with respect to y. So the derivative of y squared is 2y times 24, so that's 48xyz plus the derivative of 12y is 12. So notice that these two are the same. Now let's find the last one, fyx. So let's find fy first, which we know it's 3y squared times 4, so that's 12x squared z. And y squared is 2y times 6, so that's 12xy z squared. Now let's find the derivative of this function with respect to y. And it should be a y squared here, which I almost forgot to write. So the derivative of y squared is 2y times 12, that's 24x squared y z. And the derivative of y is 1, so times everything else, which is going to be 12x z squared. Now let's differentiate this function with respect to x. The derivative of x squared, or 24x squared, is going to be 48x. And the derivative of 12x is just 12. So as you can see, we're going to get the same thing. So the order doesn't matter. The reason why these are the same is because we're differentiating with respect to y twice, and we're only differentiating with respect to x once. But the order doesn't matter. So mixed partial derivatives are the same if you differentiate each variable the same number of times, regardless of their order. So that's it for this video. So hopefully you have a good idea of partial derivatives, and now you know how to find them. So thanks for watching.